Good afternoon, everyone, and welcome back. Thank you for joining me this afternoon. So, as I say, this afternoon, we're going to be talking about graph visualizations, and you'll actually get to turn the data that you were just looking at the metrics of this morning into interactive graphs, thanks to Cytoscape. But very quickly, what I thought I would do right now is just show everyone how to make sure that their spider is pointing at the correct environment or interpreter. The reason being that if it's not, you'll get error messages, and rather than having to jump around 10 rooms, try to firefight, it might be easier just to show people up front and make sure everyone's happy with that. Obviously, if there are problems, I'll wait in the main room for a couple of minutes, or just shout me on Slack and I'll come and help you. But essentially, once you have loaded Spider, what you need to do, and again, I've now added something so you can see my mouse when I press Control. We need to change the Python interpreter. And to do that, on the menu bar at the top, click on Tools, and then click on Preferences. That will launch this new window. And on the left-hand side, if you can navigate down to Python interpreter, and then you want to choose the radio box, use the following Python interpreter, click on the drop-down, and the one that I'm after is the -cyto environment, which was provided in the YAML file. And for me, because I've used both Miniconda and Anaconda, I want the Anaconda one. So click on that. Once you're happy with that, click Apply, and then click OK. And with a bit of luck and 10 men, that will all work as expected when the time comes. I'm just going to get my chat window up. The other thing I should mention is that I hopefully have fixed the issue with the breakout rooms, so I've recreated them. So again, hopefully that will work without too much drama when the time comes. But enough of me rambling on. Let's get on with the slideshow. So, as I say, this afternoon, excuse me for 1 second. We're going to be talking about graph visualizations. And you know, the objectives will be to understand how graphs algorithms seek to represent the data, because it's all very well and good having, you know, a great big data frame with 457 rows like we saw for season 1 data. And it's another for how that will be represented in a graph. Then we'll be discovering how to visualize graphs using 2 different approaches. So first of all, just using Network X, and I've used a very simplified version here. You won't be, I think Chris in one of the groups put on the screen, you know, the Network X version of season 1 data, and it was just overwhelming and illegible. And so we'll see that was simplified data, and then also the interactive versions. And then we will see how we're able to customize our graph visualizations just to kind of improve overall readability and convey as much information as possible. So when considering the elements that are within the system of a graph, the different ways we can represent data. There's 3 main elements, as I say, that we have to do that. And so we can start customizing or changing the visualization of our nodes or vertices, and remembering that these are like our entities or our organizations, services, or even teams. And they may have you know, a color change depending on their degree, on lots of different values. You've then got edges, and with the edges, you can change the width of those, and that could be, you know, based on how many people are moving through the service, you know, and that applies to both directed and undirected graphs. And then you've also got the layout as well, and that means how and where the nodes are going to be arranged on the screen. Now, the great thing about the Cytoscape feature I'll be showing you today is that you can actually move the nodes around on the, through the web interface. So if you've got one that's really highly connected in the middle of it, lots of other things, you can kind of pull it out to the side, and it just makes it easier to interrogate and understand. So thinking about the ways that we can customize our different things, when considering nodes, we can look at the size of the node, and this is great for continuous attributes. So a number on continuous scale, so things like eigenvector centrality, the amount of activity that is experienced at that particular node or service, and even waiting times and length of stay. You could color code those. Sorry, so you could adjust them according to the size. You've then got the color of the nodes, and this is probably more relevant for categorical values. So discrete attributes, and you can color them accordingly. We also have the ability, especially in Network X, to change the shape of the variables. At the moment, you can see in the graph on the screen, we've got diamonds there, but that is standard functionality from matplotlib markers, so it's possible to change the actual shape we see, and again, they're good for describing discrete attributes. You've then got the opacity, so how the alpha value, how see-through something is. Obviously, a lower value is more see-through, a higher value less see-through. And then obviously you've got the ability to apply a label, which could be discrete, like node 1, node 2, node 3, or it could be a numerical value, so a float or even an integer. So thinking about how we can customize the edges, we can look at the thickness, and again, that's good for continuous attributes. So, the amount of activity. So you can see here, the weights are listed 1, 2, 1, and 8 being the thickest line on this graph on the left. And then all the weights are the same on the one on the right, but all 3. You could change the color. Now again, that's I would say do it on a discrete basis, so red, orange, yellow, as opposed to a hue in between. And just remember that the edge is the same color as the source node in the directed graph. So that let's say if you were let's say it was a directed graph and you were going from this point here by A to the center point, you would color the line would be the same as the source, whatever color node that is. And then again, you can apply the labels, and as you can see here, we've got the continuous values here, but they could be discrete for whatever reason. So when we're thinking about how we can lay out the graph, the basic layout is determined by the structure of the network. And this is all very well and good when you've got highly organized networks, so power networks or computer networks. And this is, this layout is what we call the topology, which I think I mentioned first thing this morning. And so just some examples of the topology we would see in highly organized networks are visible here. And a lot of you may go, oh, I've heard of that. I remember that from, even high school computing possibly. Well, this is, the graph theory, they're using the same kind of names. So you've got your tree or forest, and that, think of your family tree there, and you can see number 5 here. You've got the ring, where each element or each node is only connected to one thing, so that's created a ring. You've got a mesh, number 6. And that is like a complete graph. So each node is connected to every other node. You've got the star. So you've got one central point, and then the kind of the outliers. So remember, if you remember the image I showed you this morning and talked about, is it a trader or a politician? And the one on the left, the blue dot, had the relationships with, trading relationships with the each of the nodes that's connected off it, similar to that. And then, you've got the bus as well. So one central edge that everything connects to. Now, as I say, this is great if something is highly organized, but the chances are, most of the time, what we'll be dealing with will not have such an organized structure. And this is when you can end up with a hybrid approach. Some elements may be like this and some may be like that, and they've all kind of got to be joined together. So you can see here, they kind of got like maybe a bus with the star and then the ring, and they're all together. They're all as part of one system, but they are unique different elements of subgraphs of it. And as I say, health systems are usually complicated systems, and they will use a hybrid of topologies, so 2 or more, in order to visualize them, so they can be understood by the eyes and the brain. And there are various different algorithms available to help visualize these complex networks when you're representing them on screen. Excuse me. And so for Network X, some of the layouts that they have, kind of out of the box, if you like, are the circular layout. And again, it looks like the ring, as we can see here. And the nose positions in a circle is most simple. And if in doubt, probably start with the circular layout and then go on from there. Next, you've got the Kamada-Kawai layout. As it says here, these are positioned using a path length cost function. And what that essentially means is the nodes that are kind of highly connected and are highly connected may be clustered together more centrally, and those that have fewer connections will be kind of pushed further out. So you kind of get a more dense arrangement in the middle, and then the less connected nodes or the outliers kind of towards the periphery. And again, you'll see that in action. You've then got a random layout, and this is just the nodes are positioned uniformly at random. And these can tend to be in a block formation. You've got the spring layout, which is otherwise known as, and forgive my pronunciation in advance, the Fruchterman-Reingold force-directed layouts. And this is a physics-based layout, and this is all to do with attraction and repulsion. So highly connected nodes may be more attracted to one another, so they kind of pull in, and nodes with fewer connections or edges will be repulsed, and they can be pushed out, or being gravity-based as well, so that can alter where it will sit, respectively. Then we've got a spectral layout, and not something I've had a great deal of experience with, and positioned using eigenvectors of the Laplacian matrix. So basically, it spreads them out in clusters, is the best way to describe that one. And then finally, you've got the spiral layout, and the nodes are just richly positioned as much as possible in an outward-facing spiral or outward leading spiral. And there are more documentation about each of these on the Network X site. And if we were going to implement these, the code we would use to do this, we would first of all assign a position variable, and using the Network X and then the particular layout you would use, and then the graph object, so G. And then you would then draw Network X with the G graph object using this position variable. And as I say, the layout would be spring, random circle, so on and so forth. And as you can see, this was a 2-step process, but if we wanted to do it in a single step, we would do nx dot draw Network X graph object, so G, comma, nx dot spring, and then there are some different arguments that can be considered. So the arguments that we can consider will be related to, for example, with the edges. We can look at arrows, the type of arrows, the style, the arrow size, going from a direct to graph. For the nodes, we can consider, do we want the labels to be printed? Do we want to consider the node size, the color, the shape, as I mentioned, and a color map? So if you want a color scheme. Then for the edges, we've got the width, which is often related to the weight, specifying an edge color or the edge color map, and the style. Is it a straight line? Is it a dotted line? So on and so forth. And then also kind of the overall elements, font size, font color, font weight, and font family. So these are all different arguments you can add in when you're drawing the graph to kind of convey more information. So now we've had a look at that. I will say let's have a look in Spider. One of the 3 files that are provided is the networkx viz example.py. And let's head over and see what we have here. Just checking the font size is large enough for everyone to read. If there's any issues, just put something in the chat or let me know. But, oh, sorry, I should move that so it opens in the black box on the screen. So you can see here, we've got our 3 standard imports, networkx, pandas, and numpy. In this one, because we're going to create, as we saw on the slide, something which is much more simplistic. We're not going to use the Game of Thrones data. We're just associating here our nodes, of which there are 5, and then they're going to have the labels, and then the edges. We are going to say, well, what are the source and what's the target, and what is the weight of each of those edges is just being declared in these dictionaries here. And then we are going to convert the 2 respective dictionaries into data frames. Then you'll remember from this morning and remember from last week, the standard function we need to convert such node and edge data frames into the graph object. So we're passing in the node and edge data. We instantiate this time a directed graph object. So these are going to have arrows. We get our ID list from the ID column of the node data. We get our labels in a data frame, we turn that into a dictionary, and then we create our tuple that's going to zip between the ID, the number, and then the description, so on and so forth. And in this one, the labels are all numbers, and then we create our edge tuples. So we go for our source, our target, we consider the weight, and then we zip through all of those to create the respective tuple, being an immutable data receptacle, considering source, target, and weight, and then it zips around the source, target, weight, so on and so forth. We add the node and edge tuples to the graph objects in 2 steps here. Then we return the graph object. So again, here we're passing into this function we've just created above, the nodes and the edges. We are here, you can see we've got our position, and so this time we're using a circular layout. So shortly, I'll be inviting everyone to work in their peer support groups to have a play with these and just try the different types of layout. We can see now we're going to define some of these additional arguments. So we're going to say for our 5 nodes, the sizes are, so this is a list with 5 numerical values in. Obviously, because there's 5 nodes, there have to be 5 values, otherwise it'll cause confusion. We've also got the node color. Now, I'm not sure if people are familiar, but these are what are called hex colors, so hexadecimal. And I'm just going to show you hex values. So, colors can be stored or communicated as red, green, blue values. And hex is just another way to work with them, and I think it's used predominantly in HTML, unless I'm mistaken. And so you can see I've just pasted in this code here. If I click on this first link, we can see this is the color that it would represent, and then RGB. We then get the equivalent red, green, blue values would be 17, 59, 78, or it can also be expressed as a CMYK, which is more to do with Pantones and printing. The old-fashioned newspapers, you remember these colors at the edge of the page, and again, those are the respective values. So all it essentially is is just a list of colors. And then we've got our edge size. And so again, we're using one of the metrics, get edge attributes from the graph object, and we want to pull out the weight attributes, pass that into there, which, as we can see, edge size is a dictionary and just telling you the information from the source to the target. And then the edge color, and then it's saying again, you know, for each source and each target, what the colors are. Then we're declaring our shape variable, so we can see here that's D, and we've got an alpha of 0.8, so that's the opacity. So with the shape, as I say, that is from matplotlib markers. So if I just go into there, you can see that the D is a diamond shape. There you go, D for diamond, but you could have a lowercase d for a thin diamond, 8 for a hexagon, asterisk, so, you know, shift 8 for a star, so on and so forth. And then finally, now we've declared all of these variables, if we want to plot the graph, and we just say plot is equal to, and please forgive my lack of PEP 8 compliance here, but essentially networkx.draw, and we're passing the graph object, the pos, which we declared up here, and we're then setting each of these arguments, so the size equals the end size, no color, so on and so forth, and then ultimately we are then going to draw the network edge labels again. So once we've done that, we will end up with this graph, as you can see on the right hand side, so much easier to understand. So if everyone is okay, I will give us 35 minutes to work on this. So we'll see each other back at 2:27. I'll open the peer support groups, but as I say, have a look through the code, have a discuss, have a play with the different layouts that are available, changing the source and target colors, and maybe when we come back, someone might be willing to show off the visualization that they've made. And again, if anyone has any issues, just let me know on Slack or come back into the main channel, and I'll be happy to try and assist. So as I say, we'll see each other back at 12:27, and I will open the breakout rooms now. Hello, everyone, and welcome back. So I hope you've enjoyed having a little play around there. I think having been into a couple of groups, there were things that kind of weren't in this example that people were trying to try. So one example would be trying to adjust the weight and the width of the edges based on the values available. So thank you to John in... John in Amiga 500, who found the answer on Stack Overflow. So I'll paste that into the Slack channel, if John, you wouldn't mind doing that, just so other people can see. But you can see on my screen here, essentially, you just create a new variable called weights with a list comprehension. And essentially what this list comprehension is doing, it's cycling through the source and the target, the U and the V, source target, in the graph object edges. And it's then using that to pull out the values from the graph object, source, target, and then the corresponding weight, and it's putting it into a list. So you'll remember the list comprehensions from the other week, I believe. And so that will then alter the graph. But some of the other things that, you know, it's worthwhile having a look at is playing around with the layouts. So you can see here, you know, the original example had a circular layout. And then, you know, I've changed it to a random layout here. And again, I apologize for the small size. And so you can see the layout is quite different each time you run it. So it was looking like this, which is also the same as you get for Kamada Kawaii. But here it was different again. So again, you know, lots of scope to play around with things. And if anyone's got any questions about something they would like to have seen, or they wanted to work out how to change that wasn't there, for example, I think we were just talking about labels for each of the nodes. If you just put that in your either your peer support group or in the module 4 channel, I'll make sure I provide an illustrated example with those, just so you've got something to work to. Okay. Anyone got anything weird or wonderful or didn't work as expected that I need to know about? Great, silence is golden. So next, sorry, just bear with me. Cool. So, sorry, I'm just gonna get the slides back up. Here we go, we talked about that. Okay, so next we'll be moving on to Plotly Cytoscape. And it is Plotly Dash, more broadly, is a framework for Python to allow you to build web applications. And Dash, Cytoscape within this Dash, Plotly Dash, is a powerful library that is used for kind of building network graphs and making interactive graphs within web apps. And so we're going to work through 2 examples during the course of the rest of the afternoon. One of them will be, I say, a static graph, in that it will render the graph, but then you're able to drag and drop the nodes to other places, which is quite good. But then there's going to be another one, which is going to be interactive. And when I say interactive, there'll be a drop down and you can change the types of measures that you want to use or to be considered, and that will re-render the graph accordingly. So that is quite interesting. And if you remember, put on the screen the other week the examples that my colleague Sean, who's previously delivered this module, has worked on. So as well as the Game of Thrones information, he's been working on something that kind of looks at the interrelationships on systematic reviews of journal articles. And so I'll try and grab one of those to show on the screen in a bit. So essentially, when we're considering Dash Cytoscape, the standard layouts that has available, they're slightly different to what we have in NetworkX, sorry. And so we have, first of all, our preset ones. And these are the nodes are termed in predetermined coordinates. So, for example, on this one, you may want the network graph that you to produce to replicate geographic coordinates. So, you know, it kind of looks similar to how it would be if you were looking at the surfaces located on a map with pins and there's lines between them. There is random, and just kind of like the random one I've just shown you for NetworkX, it's completely by chance. You've got grid, and the nodes are positioned in either a square or a rectangular grid, depending on how many you've got. Again, circle layout. You've got concentric, so where they're in concentric circles. Breadth first in a hierarchical tree structure, or coes. And this is a physics-based layout, so we're thinking about gravity and attraction repulsion, and similar to the string layout in NetworkX, and can be used in healthcare systems. And as always, there is documentation available for these. So again, worthwhile just having a little look through if there's something you want more information on. So, out of the box, there are also some more visualizations. However, they're not kind of loaded when you do the initial lard re-imports. And so if you did want to consider some of these additional layouts, there would be an additional line of code to add, and that's just Cyto and load extra layouts. And when you've done that, you will then have your codes built. And this is for kind of nested graphs within graphs, or subgraphs within graphs. Then you've got, there's various different ones here, all physics-based layouts, I think. Kohler, Euler, Spread, Dagre, and Clay. And most of these have good kind of generic applicability. So, it's worthwhile if you do want to play around with them, having a play with these and seeing how it works for your particular data. Cool. I've just seen someone talking about getting the font to change color. I'll add that to the list of things to add in. And again, if someone wouldn't mind putting these in Slack, because I will more than likely forget, and at least for Slack, I'll be able to refer back to it after we close down the session today. So when considering a dash application that we're using in Python, there's just a few things that you need to consider. So the main sections within the code, and then that needs to be, sorry, I'm just having a delivery push through the door. They just have to be considered in a particular order, and so probably no surprises here. We've got the library imports for Python, as you do at the beginning of every block of code. You're then going to define the persistent local variables, and so this is these are variables. So think about importing the data, if you like, or determining the layout, so the kind of overall structure of the page. That's done there, and this is only run once, and you'll see what I mean in a minute. We then initialize the application, and then we consider the application layout. Now this is kind of not static, because then when we go on to the next stage 5, if it's relevant, if you want to have some interactive elements, so you want a drop down or a slider or something that's going to change some of the parameters that is going to re-render the graph, basically you will change it, in the callback function, and it relies on Python user-defined functions. It'll change whatever, and then it kind of goes back to step 4 and then runs that again. So it kind of goes around in a circle, looking for changes, the changes that have been implemented via changing the callback, and then it will implement the change and then re-render it accordingly. Obviously, no change, it doesn't need to change, it doesn't need to worry about it. And that's why obviously the imports and the persistent variable creation only occur once. And then the final stage is the application run command, which when rerun, it will then, in the terminal window, it will tell us to navigate to a particular web address, which is your local machine 127.0.0.1 on a particular port, and then you paste that into your web browser, and then you see the web application itself. And as I say, let the magic commence. So what I'm going to do is step you through each of these distinct sections in the slideshow now, before we actually go through and have a look at the codes together. And then for each, both kind of a more basic and an advanced one, I'll allow you to work in your peer support groups again, just to kind of get more of a handle of these and try some of the different layouts, and you'll see for yourselves kind of how much fun it can be. And as I say, I always think this early on in some people's coding careers, to be able to create a web-based application, I think is pretty cool. So hopefully you enjoy it just as much as I do. So some of these libraries will be familiar to you, and then there's a few new ones. So again, these are within the -cyto environment file that I provided. So they are the import dash, the dash HTML components, and this is all for the HTML being web language layouts, your dash core components, and then you actually import Cytoscape, which is the library that deals for network graphs. And then we're also going to be pulling in NetworkX as well. And then because we are going to have callbacks, so callbacks are interactivity between sliders, drop downs, and the graph, we then have to pull in this additional library, dash dependencies, and from that we're going to get input, output, and state. But I will be explaining a bit more about those shortly. So with the persistent local variable creation, this is code that is run before the app initialization, which you'll remember was a distinct step, and it is only run once. So library import variable creation. And it's useful for simple applications that don't require a lot of interactivity. or where you have local variables that will never change. And so it avoids the need for kind of having to worry about more complex reactive programs, i.e. use of callbacks, reactive being reactivity. And so in the example we're going to look at, all of the data and pre-processing is done kind of in this persistent variable, local variable creation stage. And in this part, we will also set some style options for the network graph in a dictionary known as a style sheet. So if anyone is familiar, has done any web developments in the past, you CSS, cascading style, sorry, mine's just gone blank, styling. Essentially, you can determine how a web page will look and feel. Thank you. Cascading style sheets. Thanks for that, Alex. And you kind of determine it once, and you determine it at a parent level, and so all the children will kind of have that look and feel. And that way, if you change the CSS, the parameters in there, the font, the color, the you only change it there, and it'll affect everything that flows on from that. So it's quite a nifty way of controlling things quite easily. So the next stage, after we've kind of assigned those local variables, we've got the app initialization, and it's just 2 lines of code, and it will always be the same. So here we'll just say, you know, we create a new variable called app, and then we will get that from dash dot uppercase dash, open brackets, double underscore name, double underscore, close brackets, and then we'll create the server object, and we'll do that by assigning server equals, and then whatever you have called the variable above. So in our case, you know, the app object dot server. If you called that Bob, you would have to set Bob dot server, but probably best for standard nomenclature to keep it as app. And so now we'll get onto the application layout. So it does get a little more complicated relatively quickly, unfortunately. And so the layout is really comprised of a bunch of objects, and we're defining how we want these objects to be displayed on the web page we'll see before us. So to do this, you know, we're really considering the app's layout. So you can see here we've got the layout component, and again, it follows kind of HTML syntax for anyone who's familiar with that. So app.layout, and we're saying, well, that's going to be an HTML divider object, and a divider object is like a container, and these house different objects. And the great thing is that you can then apply the CSS styling sheet to it. So for this particular divider object, it's going to have a class name, and then you've got the, you know, the parents, and then the children information. So we can see it's going to have an H1. That's the largest heading size you can have, through to H6 being the smallest. And then it's going to have distinct class names. So pad header is the kind of the its nickname or the pseudonym, but then it's going to display Network of Thrones. And then if we consider the next divider class, it's going to be, you know, the text center, and this is going to be paragraph. So paragraph is like body text in HTML, and there are some links in the documentation or in the slideshow to just give you a very brief overview, and I'll just show you quickly. So I found W3 Schools as great, great for this. So as I say, the HTML syntax, so we've got information about CSS here, and then also if you scroll down, these will be what all the different, you know, H1 through to H6, header, P for paragraph, so on and so forth. Worthwhile just having a little look at. And then, you know, we declare the rest of this information, and we can even say within a divider, within a container, we can have subcontainers, and there could be different rows or different columns within them. And then we can see here, we've also got, we're defining that we want a slider. So, you know, for the reactivity, excuse me. And, you know, all of that is in there, but don't worry too much about it. You'll have, you'll get your hands on with the actual code itself. And so, as I say, within the within these web apps that we're going to create, of which there are two. There are the standard HTML components, and then there are the Dash core components. And so on the left is the kind of the standard HTML components. So this, if you go on a web page and you right click and view source, you'll start to see these. It doesn't have to be a web app. And you'll see dividers or containers. It's called divs. Your H1 through to H6, which are different heading sizes. P for paragraphs. A for a hyperlink. So if it's going to link to a different page. If you want an ordered list, there's UL, or an OL is an ordered list. And then you may have an image, which then you'll see that IMG will then have a link maybe to an FTP server or something else where an image is physically stored. And again, sometimes you can use this actually in Jupyter notebooks. If you've seen some of the notebooks I've provided, they have links within them, so you can jump to different parts of the code. And if I've ever inserted static images, again, I'm using the IMG. And then for the interactive components, so for the Dash core components, the types of things that you can have there are a drop down, which is what you'll see today, inputs, which will be a text box that you can type an input to, a slider. Let's say you want to choose between 0, 1, 2, 3, and you can slide it along. You want a button, there may be a graph, or there may be a checklist that you want to tick particular combinations of boxes on. So next, we're going to consider the callback functions. Now, the callback functions are what allow you to interact or make your graph or the web app interactive. And basically, the idea of it is this callback function will have inputs and outputs, and it's really very much related to a Python user-defined function, which you'll recognize for this bottom 3 quarters. This just looks like a standard Python function. We've got 2 inputs, data and selection, and then we either return an empty list or something else. And so we can see here that the inputs are going to be picked up from, or they're going to originate from, the hidden elements dictionary container and the child of that, which then will provide the data, and then the slider, the graph slider object, and whatever value that lands on. If you slide it to 3, it will push that 3 into there and then spit out accordingly. And the thing to remember with the outputs is it is essentially a list of kind of which element do we want to pull from and where is that located. So the elements is basically a data storage repository. And again, sorry if it's not terribly clear, it will become clearer when we see the code. And then finally, as I say, the application run command. At the end of all of this, we just have if dunder name dunder equals open brackets, sorry, open quote marks, dunder main dunder, and then app.run server debug equals either false or true, depending on how verbose you want the outputs to be. And then that will, as I say, in the terminal, tell you what URL to go to have a little look at the graph yourself. And so when we think about the graph object, the main arguments that we see in it are an ID, and this is a string, and it must be a unique identifier for that part of the web layout, because if you call 2 parts the size, 2 parts the same, then obviously we know which one you're referring to. A class name, and that's a string, and this is a CSS class for standardized styling options. We've got our elements, which I said is a data storage receptacle, and I'll talk about that more in the next slide. Then we've got our style, which is a dictionary, and these are kind of alternatives to the style sheet. You then got the layout, which has got the graph layout name and layout attributes, and then the style sheet itself. Cool. So moving on, if we're considering the graph object again, so this is all considering the layout, some of the things to look out for, as I say, we've got our parent, which is kind of this whole object here. We've then got our children, and it's always contained within the parent object. So all we're doing here really is making it explicit. We're passing in the list of objects to that element, and they're given a unique ID, so cytograph. And so, as I said, they must be unique. You can't refer to different things with the same name. The elements, as I say, is the data storage receptacle, and this is where all the pre-processing we do early doors will end up. We've got the style, and we can see there's a dictionary with the keys of width and height, and it's saying, well, I either want you to take up 80% of the screen width and a maximum height of 600 pixels, and so it'll max out at either of those two values, the screen width or the pixels. And then with the layout, we can see we've got a whole load of key value pairs, and you know, the codes, which you'll remember from the layouts which we talked about in the earlier slide, padding, node repulsion, this is all to do with the physics-based layout, gravity range, nesting factor, so on and so forth. So again, you can have a play around with these if you so desire, just because obviously depending on what data you're working with, just to make it more visually appealing and easy to understand. And so I'm just looking at the chat window, and yes, this code should look similar to the Cytoscape examples, and obviously not the Network X. So there's the simple and advanced in the same folder as the Network X visualization example. So with the style sheet, basically we're going to select how, or define how we want our node and our edges to look. And in this one, there's going to be a lot more information about the node. So we're going to define our width, our height, a background color, the content, so basically a label, the font size, so on and so forth. And then for our edge, we're basically just going to say, we're just going to define it as having the color. That's it. We're not going to define the width or anything. Yes, Dan?
Sorry, no, ignore my hand. It was just about the you picked up on the chat. So
oh, you're just waving at me. That's okay. And again, apologies, it may all seem quite abstract at this precise moment in time. It's probably going to be easier when we move through the actual code, but I thought it was just good to have additional notes on there as well. And so without any further ado, we are going to jump back into the Spider, and I will just get that going. So in the Cytoscape Viz simple file, you'll see that they've got the 6 sections that I was saying that we refer to previously. So here we're going to get our standard library input, so dash HTML components, pandas, and dash Cytoscape. So this one, because we haven't got the dash core components, you can tell automatically we're not going to have any interactivity. Next, stage 2, we are going to have our local variable creation. And so a lot of this is going to look familiar to you. So we get our nodes for season 1 data, edges for season 2, sorry, and edges for the same season. We're then going to create a cytograph, passing in these 2 variables. And that is going to spit out our elements. So basically, the data storage receptacle, it's going to have the data, as it is going to key, and then a sub key and a sub dictionary, ID, and the label for the nodes, and then the same for the edges, that considering the source, the target, and the weight. And so that spits out this great big dictionary of information. And so you can see we then call our variable elements using that dictionary. We've got our style sheet here. So considering the node information and the edge information, so you could change that to blue, red, whatever you so desire. Next, we will have our app initialization. And again, just those 2 lines of code. We'll consider our app layout. And again, our graph object, and everything we've just described in the slides. And then finally, we're skipping over step 6 here because we have no interactive features. And then step 6, we're going to run the command, have the run commands, as you can see here. I've got debug equals true just because I was having a few problems previously. Just 2 things to note. When you finish with this one, before we move on to the next one, I will remind people, but you'll just have to press Control-C on either a PC, Windows, or Linux to actually stop the kernel from running, because otherwise it's running in this continuous cycle trying to re-render the graph for you. And if you stop the kernel when you're still expecting to use it, the kind of the web address it's pointing to won't be transmitting data anymore, so you will get an error there. But without any further ado, if I run this now, we can see here Dash is running on HTTP 127.0.0.1, which is always your machine. That is the IP address of your machine from itself, and it's looking at port 8050. So if I go into a web browser, paste in that URL, and now we can see we've got our graph object. So I'm just using my mouse wheel to zoom in and out. You can see the maximum size has already been, this will be determined, remember, by that 80% or 600 pixels. But let's say we wanted to look at old Nan. If I am using my mouse button, I'm click and then drag and dropping, so I can pull it out. It makes it easier to see. Ned, I know one of the groups we were talking about Ned before, and you can see just how many edges and how many connections this chap has. I'm going to see if I can find that Kahala. Here we go. And this person just has one edge connecting them to another character. So as you can see, it's interactive. Because of that, it does make it a lot easier to unpick things, because you can pull them out of the way. And you can see in this layout, the nodes or the people, the characters with more connections or edges tend to be clustered closer together. And those with fewer edges or connections kind of tend to be on the periphery. So we've got 19 minutes all up remaining. So I would like to give everyone about 50 minutes, if that's all right, just to work in your peer support groups. Have a look through the code in just the simple example. And again, similar to the last one, don't be afraid to have a play around with what's there, changing colors. You might want to have a play with different layouts as well, and just see how that affects it, just so you can get used to having a play and hopefully not breaking it, but just discovering some more about it. So if everyone is okay with that, I will see you back at 3:50 p.m. and I shall open the breakout rooms. Oh, hello again, everyone. For the rooms I didn't get to, as you will have observed, I have ended this session a little earlier, just because I think it's important that we have enough time to go through the advanced code, just because of the interactivity in there, the callback functions, and it has got a few other bells and whistles that it's probably worth me talking through first, and then it's an opportunity. A lot of it is the same. There's just additions, so you can kind of have a look at that one as well. For maybe the more advanced people may want to think about how to filter by particular nodes. Not that it's not going to be in this code, but something you may want to go on and do if you get bored on this Valentine's Day evening. So I appreciate some people may have outstanding questions as well. Obviously, we'll pick them up in the next breakout session. But just to take you through this advanced, code, overall follows the same main 6 structures, but obviously now the callback section is going to be populated. And as you'll see here, there's quite a few more imports. So we've got our core components because we're going to have our callbacks. We've also got matplotlib, and that's actually being used as my colleague found a very interesting way to do. You pick 2 colors, for example, red and green, and you want to do the spectrum of colors that runs between them. So you get the gradient between the two. It's used for that. We then import standard scalar, and that's to normalize some of the values, just so it will work with the number of steps in that color gradient. And then obviously for the callbacks, the dash dependencies, input, output. So again, persistent local variable creation. This is all very similar. Well, this is the same. In fact, you load in the data. We've got our function to create the graph. So that's exactly the same. This is the color fader. And so again, you may want to use it for other purposes, but creates a linear gradient color fader between two colors, color 1, color 2, and then it'll work out how you want to interpolate it, and then returns, I believe, a hex value, so that hexadecimal that we saw earlier. A node color picker. This function, you pass in the data frame and the column name that you're interested in, and that will work out the hex value of the color required depending on where it's sitting on the spectrum. And so we're defining the blue and the green as the ends of that color spectrum. Excuse me for 1 second. And then basically, depending on how many increments there'll be, you kind of cycle through, just making sure I was off mute, and then it returns that. We've got a function that comes up with a load of analysis. And so these are all the things we saw in the session this morning. And then it'll load it all into one data frame and then pass that out. So we have all of these values together. We've got our create cyto dash function, which is similar, I think, to the last one. No, it's not. This is more in depth because we are loading in all of those metrics that we've just saved in the data frame above. We're creating the graph, appending all the information from the analysis. And then, you know, I know a lot of groups were looking at this about the size, sorry, the nodes and the edges, and playing around with the colors and having some funky pinks and whatnot. Then step 3, the app initialization, is the same. The layout is very similar. But obviously now we've got a drop down, a dash core components drop down for the different analysis metrics. And then we can determine what analysis metric we want to use, which is going to change the size of the nodes and the color, in fact, as you will see. So eigenvector centrality, so are they the movers or shakers? Page rank, looking at the quality and number of connections. Degree, the more connections a node has, the bigger it will appear. And then betweenness. And then moving down with the actual callback function itself, we use this app.callback. The output will be populated into the Cyto style sheet, and the input comes from the analysis metric and the value. So that was the drop down we saw above. And then we've got this user defined function basically saying that, you know, depending on what the input, you know, what we say we want, it will then filter the data in question and then spit it out accordingly. And then finally, it will run that command. And so we will get it to run. So just to have a look at that, I will run that, and we can see I've got my web app is running. Just open Chrome, put that in. So you can see all of a sudden we've got a slight difference already. We've got this drop down that's appeared on the bottom left. So with the eigenvector centrality, page rank, degree, betweenness. And if I zoom in, we can see in this particular layout, and I've just seen some amazing layouts in, I think, BBC Micro, if that's correct. In this particular layout, the more highly connected nodes or characters kind of tend to be more central, and, you know, the ones with fewer connections on the periphery. But if we kind of zoom in, if I then change eigenvector centrality to, let's say, degree, if you look very closely, the color and the size will change ever so slightly of the nodes. And the nodes, for example, let's put out this big one here for NED, because we know NED has a lot of connections, I discovered this morning. his eigenvector centrality value would be less than the respective page rank. And this is where the min-max scalar came in, or the standard scalar, because they all have different numerical values. Some will be, just floats, small numbers, and some of them will be large ones. It just kind of put them onto a scale. And then you can see this, is the interactivity. So changing these drop downs will then change the respective values, or filter the values accordingly. And so you could have another drop down, and let's say you wanted to have checkboxes, say, for different characters, and you only want to include, say, 6 characters, and then re-render the graph accordingly. So hopefully, there's a bit there to unpick and play with. And so if everyone's okay, I'll get everyone back at 4:25, not 5 as I've been continually to say. So it gives you a little bit of time just to have a little play and get your head around and make sure you're comfortable with how all of the functions work. So if everyone is okay, we'll get back together at 4:25, and I'll continue to float around the rooms and answer any questions if that's okay. All right. So hello, everyone, and welcome back. I think everyone's back in the room now. So hopefully you all got to have a play, and you got to see how the callback functionality worked, just to kind of have a better idea of what's going on there. Some people were having issues where they may have been getting weird and wonderful errors in Spider. All I'd say is just make sure that you've checked and used the correct Python interpreter. So on the menu bar, just go Tools, Preferences. On the left-hand side, Python interpreter, use the Use Specific One radio box, and from the drop-down, choose the -Cyto environment, which you will have installed in preparation for today. But if anyone is having any trouble and they can't get it working after that, please feel free to reach out to me on Slack or ask in the main channel. Also, just as a follow-on from this morning's metrics session, I will do, as I say, a solutions file, and within that kind of have all of the metrics comparing season 1, season 2, with more of an explanation. And then I'll also record a video to go alongside that, just to make sure that everyone really understands what the metrics are, how they're used, and what the comparative values mean. So hopefully that will kind of close that loop. And then if anyone wants any, I mentioned before, after looking at the simple Cytoscape graph, any changes or how to be shown things within that, again, if you put it in the Slack channel in module 4, I've tried to make some notes, but the notes are all over the place today. I know one person at least has already. If you add them in there, I will get that action to then circulate those as well, and then we'll be able to close off this module. Obviously, next week is the final full day of my training, and we will be talking about forecasting. So again, there will be a specific environment to use for that. One of the things we'll be using is a library called Profit from Facebook. So don't worry, it is, even though it's from Facebook, it is nothing like you're imagining. So don't worry if you're against social media. It's nothing like that at all. It's just a standard library, could be from anyone. But again, quite interesting to see its predictive ability for forecasting future trends. It's very good. And then also we'll be looking at other ways of just making sure it's worth the hassle of going down a forecasting method like ARIMA or Profits or whatever it happens to be, when in fact maybe there's things called naive forecasts, which will be just as good or just as accurate, give or take. So anyway, I'd like to thank everyone for coming along today. Really important that you really keep thinking about these project ideas. Anyone who hasn't come up with one yet, really put your thinking cap on. Talk to colleagues, even within departments, outside of the departments, just to try and get those creative juices flowing, because we'd like to see lots of project ideas to have some to pick from. And yeah, look, keep the ideas flowing on Slack, because other people, you may inspire other people, or you may want some questions answered. Feel free to ask away there. And other than that, have a fantastic week. Enjoy the rest of your evening, and I will see you all on next Tuesday.
Thank you, Elliot.
Elliot, sorry, just before everybody goes, I was just going to very quickly just chip in, because there was some I know some people are a bit concerned about the Python assessment, which is obviously coming up in a couple of weeks. Please don't be, I think would be the main message there. I know people are worried. There's a lot of questions around, sort of pass marks and things like that. Just to reiterate, have a read of the information that we posted up. The Python assessment is not there as a formal assessment. It's just there to make sure that you have got enough sort of core Python skills under your belt that we think you'd be able to handle leading a project that involves Python. It is nothing more than that. There will be there's no formal pass mark. They're not even formally marked. You'll get the solution after, so you can see how well you've done. And I'd advise everyone to have a go at it. Regardless of whether you're putting in a thing or not, it honestly is quite fun. I know you probably don't believe me for an assessment, but we have tried to make it quite fun. So it's nothing heavy. So please don't go worrying about it. It's the lightest possible assessment that we could possibly make. So don't worry is my overall message. But if you have any queries, obviously do shout, post in the Slack and whatever. But please don't go worrying about that assessment. It is not anywhere near as bad as you think it's going to be. I promise you. So I wanted to say that.
And I second what Dan said. It is fun, and I would encourage absolutely everyone to have a go, even if you think you may not put a project forward, which why not? But even if it's to see, you kind of check your own learning, and it may identify areas that you feel you want to improve on. But it's it is a lot of fun. So yeah, have a go. All right, guys. And Dan, I don't know if you just want to address Stuart's question in case there's anyone else who has the same problem. He'll be on annual leave that week. What should he do?
Yeah, so if anybody has got that issue, can you let me know as soon as possible? So Stuart, perhaps if you can message me on Slack or send me an email just to prompt me, I will add you to a list. We will do something a little bit differently with you. Don't panic if that's the case, but you need to let me know as soon as possible if that's the case, and we'll arrange something alternative.
Will do. Okay, thanks, Dan.
No problem.
Excellent. Thank you for that, Dan. All right, guys. See you next Tuesday, and look out for the environment file for forecasting. But until then, have a great week. Bye now.
Bye.
Bye, everyone.
Thank you.
Thank you.
All right.